Everyone, we will solve this today's LeetCode problem. So the question is Xor queries of a subarray. So this is a LeetCode medium one. Let's see what the question is asking. So we have given an array of positive integers. We are also given the array queries where queries I is from left I to right I. For each query I, compute the Xor of the elements from left I to right I. That is array left I Xor array left I plus one till array Xor till array right I, right? And return an array answer that where answer I is the answer to the ith query. So basically the question is asking us to Xor the so we have given an array we have given an array and a queries, right? A queries we need to find the answers to this queries, right? And what we need to find, so basically if queries we have given left and right values, right? Left and right indices, actually, right? This is given indexes of what? Index of array, right? And we need to iterate and each query and need to find from left to right the Xor of the values present in the array, right? So but suppose it is given left, so suppose it is given 0 until 4. So I need to do a Xor from 0 till 4, right? Xor from 0 till 4, right? That's what we need to do, and return its value and return its answer, which will come and return its value, return this value. So basically we need to do it for each and every queries present in this queries, right? So first thing is to show that we can, so basically if you want to see the example, you can see check the first example 1348. So for 01 you need to Xor 1 Xor 3, which will come as 2, right? So 1 Xor 3. So basically the Xor property, what's the Xor properties? If I go to basics, for someone who don't know what is Xor properties, so basically if a Xor a becomes 0, a Xor, so basically what a Xor a means, if you Xor with the same numbers, it will come 0, right? It is something like that. 0 Xor 0 will give you 0, and 1 Xor 0 will give you 1, right? Because in the binary this both is different, so it will give you 1. It is same, it will give you 0. Same for one case, if 1 0 it will give you 0, right? So whenever you have a different numbers, you will only get 1, otherwise in all cases you will get 0, right? One one also property of Xor is, okay, we will tell the later that you that will the logic of this problem, right? So this is the basic Xor property you need to remember, right? So basically if what we need to do, if suppose this is 1 Xor 3, so basically 1 Xor 3 is 0 1, this is representing 1, and this is representing 3, sorry, this is representing 3, right? And when you take a Xor of this, so what will you get? So first thing is 0 0 0 Xor 0 is 0, 0 Xor 0 is 0, 0 Xor 1 is 1, and 1 Xor 1 is 0. That's what I told you. And what this represent, this binary, what is it is representing 2. So that's why 1 Xor 3 is answer is 2. Same for 1 to 2, so 1 to 2 is 3 to 4, so 3 4 Xor is 7. Same for 0 to 3, so 1 Xor 3 Xor 4, right? Xor 8 0 to whole 3 indices, so that comes as 14, right? Same process, you will take a Xor of all numbers, right? And 3 Xor 3 is 8, right? So that's how you make a Xor, right? That's how you make a Xor. That's why this is happening. Now how will you solve this question, right? So first thing, a bit should come in is brute force, right? So what you will do, you will iterate in queries, you find the indices left and right, you iterate in whole array the same indexes from 0 to 1, right? So you go to 0 to 1, you will iterate from 0 to 1, 1 or 3 or something, and store its value and insert in vector and return it, right? That's what the answer, right? So you will iterate in queries and then again iterate in iterate in array of whatever left and right value you will get from the current query, right? You will find the, you will take the XOR of that particular part or subarray, whatever you call, and store that answer in, store that answer in an array, right? In an array, and at last return that array, right? That's so simple, right? But this will, how many times it takes? So for each and every time you will return in queries. So for n quantity would be for iterating in queries, that would be o of, take it as o of n, right? And is the length of query, and for each query you are iterating in whole array, right? So suppose in worst case what we can happen, so it all can happen at, it is from 0 to n minus 1, right? Put a whole length of this array, so that will be leads to n into o of m, right? So that can go to o of n into m, because you are iterating each and every time to whole array, right? So but if you see the constraints here, array length and query length can go to 3 into 10 power 4. So that will leads to TLE, right? That will definitely leads to TLE, right? So we can't do that, right? We cannot iterate in whole array each and every time, right? So we can't do that, right? Now what we need to do, so if you know this property, you will able to solve this, right? It is something like prefix sum. It is something like, take, think of prefix sum, think of prefix sum. Why I'm thinking of prefix sum? Because I cannot iterate in whole array, right? Each and every time, so I need to store something to go to each query and find out anyhow that I have stored something in previous, so I will use that and find that value to find this particular query, because I cannot iterate each and every time to repeated index, right? So I think, so that's why the problem has a solution, right? If you know the problem, you can think of a solution. The problem is we can't iterate, we can't iterate we can't iterate in whole index each and every time, each and every time, each every time, right? Each and every time. So what we can do, if you think like that, you will get the solution. So it means you need to, you need to store values some values and use that for each query, right? Right. So that's how you think the solution of the problems. So if you want to store it, think of a solution, think of the problem you have solved. If you have solved the prefix sum, you can solve this Xor properties. Why I'm saying that? See, if something is given like this, a b zod c dot d zod e, right? So if you Xor, I have told you that if you Xor with the same numbers, you will get a zero, right? I told you this is a basic property in the Xor. So basically, if something is like a XOR b XOR c, and again you take this whole value, take it as p, and if I do take a XOR of p with a b c again, what will the value tell me? So this p is a XOR b XOR c. So a can this a can XOR with a, which is 0, b XOR b 0, c XOR z 0, 0 XOR 0 is 0. So ultimately it will be neglected, right? So what is happening, if you take a XOR, so the terms are neglecting, the terms are neglecting themselves whenever you're taking XOR, right? Right. So that's what we use here, right? That's what we use here. So what I'm trying to say that is, if a XOR b XOR c XOR d and XOR e is given, so if you suppose I want to find the XOR of this b is if I want to find the XOR of c XOR d dot e, XOR e, right? So what I will do, I have stored all this, I have stored, I want to take a XOR of c XOR d XOR e. So what I will do, I will just take a XOR, again take a XOR, again take a XOR with a XOR b. So what I will get? I will get C XOR Z XOR D, because A and B will neglect it. So what I have taken, I have this XOR, I have taken again with A XOR B values. So I got C XOR D. Again, for if we want to take a XOR of B XOR C, or D XOR D, what you will do? You take a XOR with ABC, right? That will neglect it. So what we'll do? We will store we will store the prefix XOR, prefix XOR at each index, right? That's how we you think of prefix sum. What we do in prefix sum, we stored at each index a prefix sum. So we will store at each index you stored a XOR value. So what we will do? We will store A. So let's take this example, right? Let's take example, you will better understand. So what I will do? I will take a XOR of each and every index, right? So what I will do? I will start iterating 0. So the first, I am making n plus 1, right? I am taking n plus 1 array. The first index will be 0, the second index will be 1. Now the third, which is second, right, it will be 1 or 3, whose value is, so let me write in below, right? Whose XOR will be 1 XOR 3 is 2, right? Next is 1 XOR 3 XOR 4, which will be, which is same as 2 XOR 4, right? Because I know this value is 2, so 2 XOR 4 is to if you see this, 2 XOR 4 is something like this: 0 1 0, and this will be 1 0 0, right? So this is 1 1 0, which is 6, right? So it will be 6, same as now 6 XOR 6 XOR, which is 8, because 8 is at this point, because we are storing at each every position from starting to end. So this is the prefix XOR, right? So 6 XOR 8 is something 110, and this is 100, right? So this will be, if you take a XOR of this, so this will be 1, this will be 1, this will be 1, this will be 0, right? So what is it is representing? So 0 1 2, so 8 plus 4 12 plus 2 14, right? It is representing 14, right? It is representing 14. So we have a XOR value at each index from starting to its current index, right? From start to from start to index I, right? Index I, right? That's what we have, right? So this is 0, this is 1, this is 2, this is 3, this is an 4, this is 4, right? So we have index as 0 1 2 3, 0 1 2 and 3, but we have the values of XOR at 1 2 3 4. It has some reason why I'm doing this. You can also start from 0 part, but I have started from 1 part, right? Why I'm doing this, let me tell you. Now the queries are this. So we have our prefix XOR, we have our prefix XOR, this value, or write it in different part. Okay, something, okay, write it at this different. We have a prefix XOR here, right? 0 1 2 3 4. Okay, so okay, one thing also note to here is the basic property, that if you take a XOR value, if you take a number x, and if you take a XOR with 0, it will be same as number. Why I'm saying that? Because suppose there you have given 0 0 1 0 1 1 1 0, and if you take a XOR with 0, it will not affect that number. If there is 0, it will be 0. If there is 1, it will give 1. If there are 1, it will give 1, otherwise 0, right? So that if you take a XOR with 0 to any number, it will not affect that number, it will return with that. That's why I have just initialized with it 0, because you need to take a XOR with 0 XOR 1, right? So it will give you the same number, it will give you the same number. That's why I have initialized with it 0, right? So yeah, this is how this works, and this is queries 0 1. Now if you, this is r value and this is left value, right? So 0 1, so from 1 to 0 you need to find it, and you have that number. So I have considered at from first index, and this is given from zeroth index, right? So one will be at position 2, so this will be r plus 1, and this zero will be this position, right? This zero will be this one, so this zero is included in this, right? But when you take a XOR with someone, I don't want to include this, so what I will do, I will take a prefix XOR r plus 1 XOR prefix l, prefix XOR l. Why I'm doing this? Because this l is representing the previous one, not this zero, but its previous one, and this previous one is the same as zero because we have started from one index. Don't be confused, we have started from one index, so this one will represent the second part which we want, the two XOR we want, and this l is one which is included, which is in our prefix XOR are not included, and we want to take a XOR with it because we want to neglect that, right? This is something like same as summation, right? So a plus b plus c plus d, and if you want to take a sum of, you have a stored the prefix sum, and you want to store you want to take summation of c plus d, so what you will do, you just take a summation minus a plus b summation, right? That's what we do. So this is the same thing, this is the same thing. I hope you are understanding, right? If you're not, just take a pen and paper and you will better understand. So that's what we are doing. So this r plus 1 is 1, so at 2th position this is 2, right? So 2 XOR, and the L is 0, which is 0, so 2 XOR 0 is 2. So if you see, the first answer is 2, right? The first answer is 2. Same goes for second. Now this is 1 2, right? So 2 is the index, and here with the 2 is at 6, which is r plus 1, so this is 6 XOR, and this is 1 which is at this one, right? So what I'm doing, r plus 1, but l will be the same, so this will be 6 and this will be 1, which is 6 XOR 1. So 6 XOR 1 is, what is it will be, 6 XOR 1 is 7. How it is 7? So see, 1 0 0 1 1 0, and this is, okay, let's me tell you, 1 1 0, and this is 0 0 1. So if you take a XOR, it will give you 1 1 1. So this is 7. So this is how this is working. It is just neglecting its previous value when you are taking the XOR value. Same goes for 0 comma 3. So 0 comma 3 is till 4 here, right? 3 is at 4 position, which is 14, and 0 is 0. So 14 XOR 14 XOR 0 is 14, right? This is how we solve this question. Same for 4, which is 3 comma 3, and 3 comma 3 is, so 3 is at 4, which is 14, and 14 XOR, and this is 3, which is 6. So 14 XOR 6, which is 8. You can take a binary percentage. So basically what we do, we will store all the numbers at current index and solve this using that, right? Let's just implement it. I will explain you so much and give you very much time. So let's implement it, right? So we will take a prefix XOR of n plus 1 size. Why n plus 1 size? Because I don't want to make complex, just want to make it more suitable for me, right? And prefix XOR at the first position will be 0. I can also initialize it with here, but for clarity I have write it here, right? Now what I will do, I will iterate in whole array. I will iterate in whole array from 1 till n. Why I'm iterating with 1? Because I have already slashed with 0, right? So it's just an implementation. How you want to implement it, it just depends on you, right? So this is prefix XOR, and this will be I minus 1 XOR the current value, which will be I minus 1 because we have started from one index and we want the previous value. So array I minus 1, right? This n plus 1 is just for storing the values of XOR. So we have taken a XOR value just like we do in prefix sum, right? Now we will iterate in whole queries. The first part is q1, and the okay, the first part is 0 and the second is q1. So also we need to store, we need an extra answer array to store our answer, right? So that would be answer dot push back. Now what we need to push back, right? What we need to push back, right? So we need to take a XOR of r plus 1. Why r plus 1? Because this is given a 0th index, right? And we have stored in 1th index, so I need to take r plus 1. Xor with, so this L needs to be included in our array, right? But we have taken from 1th index, so this L would not be included with us, so that's why I can simply take it as L, right? I don't need to take L minus 1 because I have started from 1, so this L is automatically is previous one, right? And this value would be stored in our value, and that would be our answer, and return this answer, right? So this is how we solve this question. Let's just run this and we will discuss its time and space complexity. Okay, we have not commented something. Okay, let's see. Yeah, let's run this again. So I have explained you in very basics way so that some beginners can also understand. Let's just submit it. So let's just submit it. Yeah, we have passed all the test cases. So what is this time and the space complexity for this problem? So time complexity would be, the first is we are iterating in whole array, so that would be O of n. So okay, I have told you in brute force that this n would be, okay, so let's take this n is that n is the size of array and m is the size of queries, right? Whatever you want. So here n O of n, which is the size of array, and also I'm iterating in whole query one time only, so that would be O of n plus O of m, right? O of n plus O of n, right? The space complexity would be, so I am taking an extra prefix and added to store the Xor one, right? So that would be O of n, right? Now can we optimize it further? So if in the time complexity we cannot, but in the space complexity we can. So what I will do, I will don't take this extra prefix array, I will use this given array. How? So basically what I will do, I will just use the given array. So I need to now change the whole process to the 0th index, not 1th index, right? I will change it whole to 0th index. So how we will do, we will just change to 0, this will be n, right? Now the starting point, the array 0 would be the same, right? The array 0 would be the same, so we will start from 1. Now this array would be I, array I minus 1. Just take the Xor with array minus 1 with array I, right? What I have done, I have taken previous one and take a Xor with the current one and stored in the current one also. So we don't need to extra do that. Now we need some changes here because we are not, we are at 0th index, so r will be the same, right? The r will be the same, and this l is needs to be included, so I can't take a Xor with it, otherwise it will get neglected. I need to take l minus 1. But when you do l minus 1, l can be possible 0, right? So I need to check at whether this l is greater than 0 or not. So if l is greater than 0, I can take this, I can do this into value 0. I can use I can simply take this add l minus 1. Otherwise I will simply store array r in my value, right? That's how we will find this, right? So let's just run this, it will also work. So for not doing this process, I am just initializing with n plus 1 because we need to check for l minus 1 that whether l is greater than 0 or not, right? Because that will be negative if you uh, 0 minus 1 will be negative, right? So let's just submit it, and you see that we have successfully changed space complexity to O of 1, right? And the time complexity will be the same. So there are the third one. So this is how we solve this question. Hope you understand it. Thank you so much.